Welcome everyone to today's session. This is going to be a festive session of unboxing design patterns with Santa, and I'm going to be the assistant of Santa. So, Santa has a special message for you, how he get prepares for this festive event using the design patterns. So let's dive into that. Before going further with today's session, I want to say thank you for organizers, the Greg Sati, also known as Azure Greg, and as well as Richard for organizing Festive Tech calendar every year. It's another year with those great contributions, and this is my third year of contribution, and I'm truly glad to be giving back to the community with this Festive Tech spirit and trying to uplift everyone. In addition to that, part of the theme of these sessions is to raise for the Raspberry Pi Foundation, raise some funds. And this is a global nonprofit organization, Raspberry Pi Foundation, with a mission to help young people learn how to code, create and solve meaningful problems using the technology. Now, more than ever, our mission has never been vital for those communities. We, we believe that every young person, whatever their background and wherever they are in the world, deserve the opportunity to learn digital skills and gain confidence to create with digital technologies. So please check the Raspberry Pi Foundation on Festive Tech calendar and donate whatever you can. Thank you. Now let's look at the agenda. But before looking at the agenda, I'm Elhan. I'm Azure MVP and as well as MCT. Since 2007, I have been helping the students to succeed with Microsoft technologies. For the last 8 years, it was more about Azure. I'm speaker, author, and cloud architect. I have 24 plus Azure and M365 certifications. And of course, this didn't happen overnight, but and my first certification actually, I earned it in 2006 from .NET Framework Technologies. So I'm a cloud marathoner founder, and I'm encouraging everyone in that platform to start their cloud journey, learn as a group and share, and find the ways how you can help your customers. So I'm a tech geek and as well as lifelong learner as a long-term Microsoft certified trainer. Starting from New Year, I'm also going to be the Microsoft regional lead. So if you are an MCT and need some guidance, feel free to reach out. So you can also see my social links there as a LinkedIn, Twitter, or blog. I blog on thecloudmarathoner.com, but I'm mostly posting on LinkedIn and tweeting about that. So check those things if you want to stay up to date with latest cloud automation and security in Microsoft Azure and as well as overall in cloud platforms. All right, let's look at our agenda tonight. So tonight uh, we will start with why architecturing matters and what you will get by setting up your architecture right and how you can help the Santa in doing those. Then we'll look into what is the cloud architecture. Then we'll transition into design patterns to the rescue to put them in work for noble cause and make sure that we don't repeat the same mistakes that we did before in for preparing the our architecture and factories for production for festive and months. And finally, if you have any question and answers, you can put them in the comments. It's going to be a recorded session, so all the references and everything, you can get them from the GitHub link that's going to be posted on LinkedIn and as well as on Twitter. Let's look into the why architecture matters. So, well, it is not an easy task to prepare for Christmas for Santa. So he basically needs a team he to work the architecture and execute our plan. So team of volunteers and elves need to help the Santa. So what are in this infographic that we have, we see some volunteers and glimpse into the process and steps of preparation to build this set of buildings, which are in our case are places to live, or they can be a factory. It's basically a process of planning, making sure that architecture, you know, taking into account all the aspects of the design, and it cannot happen in vacuum, and it should involve everyone in this process. It's obvious that in order to have this sound architecture and being prepared, you need to have architecture that starts with identifying the scope of the solution. You need to identify and verify the requirements, and then you need to build proof of concept, and then you need to have a team that will, start building that, and it will go on and on. And you may ask what it takes to build an enterprise scale architecture. Well, it takes more than that. It takes all the components to talk to each other, where nowadays enterprise architecture are moving to the cloud architecture for innovation and agility. Let's look what is the cloud architecture. So cloud computing architecture refers to the components and subcomponents required for the cloud computing and for building the snowflakes and all this majestic festive stuff. These components typically consist of front-end platform, fat client, sync client, mobile, you name it, backend platforms like servers, storages, and networks, a cloud-based delivery, and the network, of course, internet connectivity, intercloud, it's all very important to have in place. Combine these components, make up a cloud computing architecture. So we need to mix those components and recipes in order to get a good sounding, reliable, scalable cloud architecture. The backend in this diagram that you see refers to the cloud architecture components that make up the cloud itself, including computing resources, storage, security, mechanisms, management, and more. So, but okay, we are here to learn more about design patterns that cloud is using, right? So, what are those design patterns? Let's look. So, software architecture design patterns are reusable solutions to common problems that happen during the design and development of software systems. These patterns help software architectures and architects and developers create robust, maintainable, and scalable software by providing tested and proven design solutions. In this diagram, we can see some elements of design pattern like MVC, model view controller, like broker pattern, and many more. Let's consider specific software architecture design patterns in our next slide. So, so what are those design patterns that we can group together? Generally speaking, you may have creational patterns, structural patterns, and behavioral patterns. So, as the name suggests, creational patterns stands for have to do a lot with creation of the objects of those, reusable objects. These patterns are designed for the instantiation of those classes and of those units of building blocks. Creating the objects required in the conventional format may result in additional complexity to the software design or even design problems. So these creational design patterns solve this problem by controlling the object creation process. Then we have structural patterns. Structural patterns are useful in creating larger structures from smaller individual parts that are in general or of a different class. This pattern can also be used to ease the design by recognizing a basic method for recognizing relationships among entities. The main idea behind using the structural patterns is to increase the functionality of the classes involved in the software without making many changes to its fundamental composition. And finally, we have behavioral patterns. Behavioral patterns are those design patterns that describe and identify the interactions between different objects. Making use of behavioral design patterns can reduce complicated flowcharts of the software design into simpler interconnections between different objects of the class. So this is all good, but what are the known cloud patterns that we can use? And what are they? Well, if the question is why knowing the cloud design patterns important or helpful, I would say that in the cloud, we have an answer for it. In the cloud-based system, failure is going to happen. It's going to happen for sure. So your architecture needs to focus on eliminating a single point of failure that can bring down the entire system. So you can have cloud design patterns from known big solution providers like Amazon, Google Cloud, and Microsoft Azure to help you in this endeavor. And I'm going to share those links at the end as a references. So, but wait, those cloud design patterns in AWS, in Google Cloud, or Microsoft Azure, are they all same or each have different approaches? So let's look at common cloud design patterns that exist in each of these cloud solution providers so you can have a straight guidelines no matter what cloud solution provider you want to use in order to build those systems to help the Santa. Well, there are common cloud design patterns and each pattern describes the problem that the pattern addresses, consideration for applying the pattern. So most patterns include code samples or snippets that show how to implement the pattern on a specific cloud. However, most patterns are relevant to any distributed system or public cloud, whether it is AWS, Azure, GCP, or any other platform. So let's start with the first one here, anti-corruption layer. So implementing a facade or adapter layer between a modern application and the legacy system. It stands for it. It helps with those type of, those type of implementations where you want to have anti-corruption layer. With the circuit break, it will handle faults that might take a variable amount of time to recover from when connecting to a remote service or resource. This can improve the stability and resiliency of an application. Then we have a claim check. Split by splitting a large message into a claim check and a payload to avoid any overwhelming a message uh, bus that will be handling it. So retry with a backoff is another pattern, or it's simply called retry, enabling an application to handle anticipated temporary failures when it tries to connect to a service or network resource by transparently retrying operation that's previously failed. Then we have Sega orchestration, which manage the with this pattern you can manage data consistency across microservices in distributed transactional scenarios. A saga is a sequence of transactions that updates each service and publishes a message or event to trigger the next transaction step. And the Saga orchestration pattern helps preserve data integrity in distributed transactions that span multiple services. In a distributed transaction, Multiple services can be called before transaction is completed when the services store the data in different data stores. It can be challenging to maintain data consistency across these data types. Then we have three more here, and you can check them all with the links in the references. All right, so next thing here we have cloud design pattern, that where we will deep dive into some of the patterns like anti-corruption layer. This is the design and illustration of the diagram that's doing this, and these specific design patterns solves a specific problem. The problem is most applications rely on other systems for some data or functionality. For example, when a legacy application is migrated to a modern system, it may still need existing legacy resources. New features must be able to call the legacy system. This is especially true of gradual migrations, where different features of a large application are moved to modern system over time. So what would be the solution for it? Well, one solution is to isolate the different subsystems by placing an anti-corruption layer between them. This layer translates communications between two systems, allowing one system to remain unchanged while the other can avoid compromising its design and technological approach. Again, this diagram that we have, it illustrates an application with two subsystems. We have subsystem A and we have a subsystem B. And here, subsystem B, subsystem. So, what is subsystem A and B? With subsystem A, you call to subsystem B to an anti-corruption layer. Communication between subsystem A and the anti-corruption layer always uses the data model and architecture of subsystem. Calls from the anti-corruption layer to a subsystem B conform to that subsystem's data model or method. The anti-corruption layer contains all of the logic necessary to translate between the two systems. The layer can be implemented as a component with an application or as an independent service. So when to use this pattern, you may ask. A migration is planned to happen over multiple stages, but integration between new and legacy systems need to be maintained. And as well as when you have a use case where two or more subsystems have different semantics but still needs to communicate to each other. For those use cases, you can use this anti-corruption layer pattern. So you don't want to use this pattern uh, because it's not suitable if there are no significant semantic differences between new and legacy system. Okay, now next one that we have here is claim check pattern. And with this pattern, you split a large message into a claim check and payload. Send the claim check to the messaging platform and store the payload to an external service. This pattern allows large messages to be processed while protecting the message bus and the client from being overwhelmed or slowed down. This pattern also helps to reduce the cost, as storage is usually cheaper than resources units used by messaging platform. Now, in addition to that, you also have well-architectured framework in each cloud that you can utilize. And these are the pillars and what they provide. So I will have the references in next slide to help you in your cloud patterns and cloud architecture journey. Here it is. First set of references that covering the architecture-centered design guides in Google. You have perspective guidance on cloud design patterns. You also have data management patterns in Azure and messaging patterns, and as well as design and implementation patterns that you can utilize. Again, I will make this presentation available, these clickable links in the it's going to be all in the comments once this video is published, once you have this session in place. Next set of references is where you can start learning about cloud architecture, design patterns, and as well as some of the Azure architecture and as well as cloud architecture topics. So you can start from Microsoft Learn, as usually we do. You can check the Cloud Marathoner study guide. We also have Thomas Maurer study guide. We have official practice test from Microsoft for Azure Architect exam. So then we have John Saville study cram. We have labs and exercises, Azure Architecture Center, Microsoft Exam Emulator, practice assessment. So there is a number, there's a big, massive set of resources that you can use. So please check this, uh, please check my session GitHub repo link that's going to be posted. In addition to that, if you want to learn by watching, you are more video guy that want to have a proper course to learn about Azure solution architecture, design, infrastructure, and solutions, then you can check this LinkedIn course, which I made available to you if you check my LinkedIn profile. It's there for you. So please check this resource so you can be a helpful volunteer or elf for Santa's efforts. In addition to that, if you are more of a mobile person that want to have a QR code for those resources, you can also check these QR codes. You can take the picture, can scan it, so you can go directly to the resource in order to start learning about cloud architecture and patterns, and as well as be a helpful elf to help the Santa during this festive season. All right. Thank you all for being here. In summary, I want to say that we learned about Snowy Cloud architecture. We learned about how to build Snowflake patterns that work with the patterns and different cloud architecture patterns that we went through some of them, and we looked into some common ones across any cloud where you can be. We also look and provide some information on different Snowy Cloud factories, and you learn how to get started with Festive Cloud architecture to be a productive person. And we look into a set of references to guide you in continuous learning and pass on the snowy hills of cloud. Finally, thank you very much, everyone. I'm going to share GitHub repo with references and everything on my LinkedIn post. So please check it out. Thecloudmarathoner.com also will have a blog post about that. But again, thank you the organizers. Thank you everyone being part of this awesome event. Don't forget about the Raspberry Pi Foundation and stay safe and happy holidays to all of you. Bye.